All right, let's talk about the secret life of, well, everything around you. Have you ever really thought about how the objects you use every single day came to be? Today, we're pulling back the curtain on that incredible digital journey, from a simple idea in someone's head to the physical object you can actually hold in your hand. Let's dive in.
I mean, really think about it for a second. The process almost feels like magic, doesn't it? An idea just becomes real. But it's not magic at all. It's an incredibly detailed, fascinating, and structured process. And today, we're going to map out exactly how that transformation happens, starting right at its secret digital core.
So here's the big secret. Every single product designed in the modern world starts its life as pure data. The best way to think about this is as the product's digital DNA. It's this central foundational blueprint that contains every single piece of information about it, long before a single piece of plastic or metal is ever touched.
Now, this digital DNA has a technical name. It's a CAD/CAM database. And this isn't just some random folder of files on a computer. No, it's a highly organized, structured system that acts as the single source of truth for the entire team. This means the designer, the engineer, the person on the factory floor, they're all looking at the exact same plan. And that is absolutely crucial for preventing expensive, frustrating mistakes.
To really get a feel for this, just imagine the master blueprint for a massive skyscraper. It's not just showing you the shape, right? It's detailing the plumbing, the wiring, the exact type of steel needed for every single beam, the thickness of every window. That level of insane detail, that's what this database is for a product. It's the whole shebang.
So what's actually in this digital blueprint? Well, you can pretty much break it down into two main types of information. First, you've got the geometric data. This is the what it looks like part, all the points, curves, and surfaces that define its exact shape. Then you have the non-geometric data. This is all the how it's made stuff, what materials to use, the tiny acceptable measurement errors, even the precise path a robot arm will take to assemble it. You need both to make anything real.
Okay, so we have our digital DNA, we have all the data. But raw data isn't a product, right? How do designers actually turn that data into something we can recognize? Well, this is where they basically become digital sculptors, using some incredibly powerful modeling tools. Let's look at the two main ways they do it.
On one side, you've got something called wireframe modeling. This is the most basic approach. Think of it like drawing a see-through skeleton of the object. You can see all the edges, but there's no substance, no skin. It's fast, but simple. Then you have surface modeling. This is a huge leap forward. This isn't the skeleton. This is the complete, continuous skin of the object. It defines every single curve with mathematical precision, which is absolutely essential for things like the sleek, aerodynamic body of a car.
And this is where designers have to make some really important choices. Just look at the trade-offs. A wireframe, incredibly fast, perfect for just sketching out a quick idea. But the realism is super low, and you can't really use it to actually manufacture something. Surface modeling, though? Yeah, it's slower, but it's fantastic for those complex, beautiful shapes we see on modern products, and the realism is off the charts. It's all about picking the right tool for the right stage of the job.
So, our digital model is sculpted and looking perfect. Now for the most exciting part of the journey. How does it break out of the computer and into the real world? This isn't just one chaotic sprint to the finish line. Nope, it's a super organized, step-by-step process we call the design lifecycle.
This whole path is broken down into these key stages. It all starts with conceptualization, literally just sketching out rough ideas. Then it gets serious with detailed design, where that precise 3D model is built. But is it strong enough? Will it overheat? That's where analysis comes in, digitally stress testing it. Once it passes, you get documentation, the instructions for the factory, and maybe a physical prototype. And only then, after all those hurdles, does it finally move to full-scale manufacturing.
You can see why this process is so important, right? Every single one of these stages is like a critical quality checkpoint. By finding flaws and making improvements in the digital world, engineers can save a ton of time and money. It's all about catching a mistake on a screen before it becomes an expensive physical problem, ensuring that the product that finally gets to you is the best it can possibly be.
Honestly, this quote just nails it. This structured workflow isn't just about making things. It's about making things better. It lets huge teams of people work together smoothly, it drastically cuts down the time it takes to bring a new product to the market, and, most importantly for you and me, it leads directly to higher quality, more reliable products. It's the hidden engine driving modern innovation.
So at the end of the day, every object around you has this incredible hidden history, a digital life of being designed, modeled, tested, and perfected, all before it ever really existed. And that leaves us with a really cool question to think about.
As artificial intelligence starts to play a bigger and bigger role in this process, what are the products of tomorrow even going to look like? What new things will be possible? Something to chew on.